Yo, what's up, guys? Welcome, episode 35. I really didn't really feel like filming this episode today. Being a really long day. Just one of those days where I just feel like doing nothing, I guess. Being frustrated with some homework assignments and all that, and I guess this day just killed me. It was kind of a later night last night, too, so probably gonna record this video and get a good night's sleep. Probably relax and watch a show. We're gonna film this first. So, again, shorter video, probably one or two questions. So, let's get to our Pokemon sound of the day. It is a Clefairy. This is a pretty interesting noise. Nice. Nice. We're gonna get straight into our problems today. Oh, jeez, that's bright. Fuck. I had so many graph problems, dude. Jeez. They've been doing graph problems forever. Yeah, we're going to probably just a stack and a linked list problem, I would assume. Ow, my eye. God, man, that's bright, dude. Fuck. Okay. Swap those in pairs, reverse linked list 2. God. Let's check out our stack one, actually. Stacks and queues. Put this back in. Ow. Gosh, man. Next graded node in linked list. Interesting problem. Might require a stack. Alright, take a look at this problem. We have a linked list with n nodes. For each node in the list, find the value of the next graded node. That is, for each node, find the value of the first node that is next to it and has a strictly larger value than it. Okay. Turn an integer array answer where answer I is the value of the next graded node of the ith node one indexed. If the ith node does not have a graded node, set I is equal to 0. Trying to think here. Turn an integer answer I when answer I is the value of the next graded node of the ith node. Okay. Start off 1, 2, 3, 4, 5. So 2 is 7. Then we don't have a higher node than 7, so it's 0. We have 4. We got 5. 3, we got 5. Then 5. Since there's nothing after, we put 0. Interesting problem. Oh, jeez. Oh. Honestly, I don't have obviously this is probably a stack problem. I mean, we click the stack. While code is equal to head, while code is not equal none, code is equal to code on next. Okay, obviously we want to loop through, right? And we want to start from our first value. How are we going to use the stack in this case? That's the thing I don't know. Let's kind of visualize it. 7. We got 4. We got 3 and 5. Okay. Right now what I'm thinking is that we have a while loop on a stack. Let's just, let's just like, let's just visualize our stack right here. So this is our stack. And then obviously we're going to start at this value. So I guess we add 2 to our stack. Right. And then we loop to the next value. We add 7. Trying to think here, how would we use a stack to solve this problem? Well, we put in 7, take it out. So I guess we have our current value, which is 2. We're looking for the next biggest value. So I guess we compare from our current to our next. Mm. 7, 2. I'm not sure. We compare our current is 2, then the... Wait, hang on. So our current is 2, right? So I guess we don't add 2 to our stack. We keep looping until we find, so then we add 7 to the stack, right? We check, is 7 we have our current. We check is, we add 7 to the stack. We check is 7 greater than cur? Yes, it is. So then we add 7 to our array. Right? Then 7 is our new current. Right? So 7 is our new current. And we take this out of the stack. We go... That's not going to work. I don't know. I don't know how to do it. I'm not sure. Not sure how to approach this problem. Okay, so it's either... I'm trying to think. It's either we got to use 2 loops, so, you know, we loop this, right? We have our actual value, right? Like our actual current value. Our current is this. And then we keep looping after this for and adding and adding and adding until the stack finds the value that's not here and then appends it. That's the only way I can kind of think of it. I don't think that's the proper way to use a stack in this problem. Like, I just don't see... yeah. Let's create an array. So obviously we're going to need it to store everything. I need help from the internet, I'm not sure. Is equal to... So they're saying to use an array, which I think is cheating. I mean, but whatever, I'll do it. Append our array. Sorry, I was opening a code up out yet. Result. Let's get rid of this nubs array, dude. Let's initialize pointer. Loop through. Yep. Loop. Populate nums. Okay. For I value enumerate nums. Yeah. All stack. Stack is not empty and the stack is less than nums. All stack and stack minus 1 is less than nums I, right? Less than value. Whoops. God, man. This means value is greater than. Same thing, but it's a little easier to read, I feel like. Stack -1. Obviously, we want to find the value that's greater. Is greater than nums. Obviously, then we want to pop. We want to append that value. Otherwise, if it's not empty, we just want to process our next value, which would be stack that append, right? Length. We return here, return array. It's too far, we need that here. Okay, let's go through this code because I'm a little, I feel like we were thinking about it the right way, but I just like, obviously we can skip all this. We're just pretty much working with an array here. So we enumerate for iron values. So let's make our stack here. Our stack, and we have an array. Let's do 2, 7, 4. Oh my gosh, dude. 2, 7, 4, 3, 5. Right. Looping through our index and our value. So we start off at 0. So we start off here. While stack is false, so we append I, right? So we append 2, right? Then we go through again. We go to our next value, which is 7. So with 7 greater than 2, while stack is not empty, it has something in it. And our value is greater than the top of our stack, then we pop the index. Then index is equal to stack.pop, so we pop. Array index is equal to value. Wouldn't that append to? Like, bro, what? That's the way I'm reading it, bro. Alright, val2. Okay, let's go back. So we do so we push 2, right? Push 0, index of 2. Oh, wait. Stack.append I. Okay, right. So we are appending okay. We have 2, 7, 4, 3, 5. And we are working with this here. So we have an empty stack. We have an empty stack here, right? So our stack is empty. We process our first value. We're appending our actual index, right? So we append 0, right? And we go to our next value, while stack, and value is greater than num stack minus 1. While stack and value is greater than num stack minus 1. Our value, okay. So, which it is, then we pop, right? Pop 0, update, result 0 is equal to 7. One val 7. Stack is 0. 7 is greater than. Bro, what the fuck? I'm so fucking confused right now. I think it's just because I'm fucking out of it, I guess. I don't know. Okay, let's look at this again. Jesus, dude. Oh my gosh. Stack is 0. Push 0, index of 2. 2, 1, 7, 0. That's our stack. Okay. 7 is greater than 2. Pop 0, update result 0 is equal to 7. Okay, array index. So you pop our index. So 0. So array 0 is equal to value. Ah, okay. Fuck, man, that took so long to fucking understand. Okay. So here's our new array here. So we pop 0, right? And 0 so value shown is greater than nums stack minus 1. So nums 0, which is 7, is greater than the index value of 0, which is 2. So we index, we pop, then we array index is equal to value. So then we do our first is equal to 7. Okay, we're getting somewhere. We started here, now we're moving to this value. So we check 7. There's nothing in the check, so we add 7 to our stack, right? Go to the next value. We look at 4. What is greater than 4? Seven, and then we add, oh my gosh, sorry. And I'm already messing it up. 7, we add stack.append I, so we add 1. Right? Then, go to the next phase. 4. We have 1 in our stack, right? While stack and value. So the value that we're looking at is 4 is greater than nums stack minus 1, which is not true because that's 7. We append, right? We push 2, which is index of 4. Then we go again, we do the same thing, we push 3. We push 3. Didn't work out, we go again. Sorry. Can we look at 5? 5 is not there, so we add 5 to our stack. Oh, no, we add 4, sorry. We add the index. Okay. Right. Maybe not. Push 3, index at 3, right? We have step 5. We're at step 5. Looking at I4. Sorry, I3, sorry. So we have 3, because we were looking at 7. Wait, no, hang on. We added 1 here, right? It's so confusing to understand, holy shit, dude. Okay. We're looking at I's 2 and 4, right? So it was 4 greater than the top of our stack. No, it's not. Three, it's 2, no it's not. Three, first index at 3, right? Okay, so now we're looking at step 5, we're at 4, 5. Looking at 5 here. We're looking 5. This is the top of our stack now. Okay, yeah, this is the top of our stack. 5 is greater than 3, right? So 5 is greater than 3. So what do? We do our index is equal to stack.pop. So we pop from the stack. And array index. So array 3 is equal to value. So 0, array 3, 1. Array 3 is equal to value. Array 3, so we have actually, okay, we're here, right? So this is our 7. I'm just going to replace it with zeros just so we can visualize it a little better. We have 5 zeros. Right, so we're at 7. We have 3, so 0, 1, 2, 3. So we replace this one with 5. 5 goes here. We pop that. Then we keep going through the stack because we're in a while loop here. So we do is 2 greater than numstack minus 1. So yes, it is. Yes, because we're looking. So 5 is greater than 2. So we pop that and we put it equal to 5. So 5 goes here. And we have 1 left on the stack. So is the top of the stack, is the value that we're at 5 greater than numstack minus 1? No, it's not. One. Result 2 is equal to 5. Push 4, index of 5. So then we push 4 onto our stack. And I guess we leave our stack how it is. So technically we have 4, 1. And then obviously we return our array, which is what our answer is here. Okay. Interesting way to think about it. Tough problem though, definitely. Tough me. I know that's a technique for stacks, like using the indexes and enumerating with the indexes. But it's just, man, it's hard to think about it like that. It's a great way to think about it, but yeah. This one doesn't do it with an array, it actually does it the normal way. We're doing the same thing. We're doing something similar, a similar technique. We're just not using an array, we're using a linked list here. While stack and stack minus 1 is less than head.val. Interesting. Took a little while for that problem. But it was good. It's definitely a good problem. Let's check out some other things. Let's actually do a linked list one. Let's do swap nodes and pairs, and then we'll call it like that. Okay. Given a linked list, swap every 2 adjacent nodes and return its head. You must solve the problem without modifying the values in the list nodes, i.e. the only nodes themselves may be changed. Okay. What the fuck are we doing here? Okay, we're swapping each adjacent number. Okay. I think I have an idea about how to do this one. While cur does not equal none, we want a loop. So cur is equal to cur.next, just a basic loop, right? But we want cur2 is equal to head.next, so we can get that next value, right? Check an if here. If I guess if cur does not equal none, sorry, if cur and cur, if cur and if cur does not equal none and cur2 does not equal none, then we want to make the swap. So cur2 is equal to cur2 cur. We make the swap. Then we increment, right? Cur is equal to cur.next. Cur2 is equal to cur2.next, right? Let's just see what that does. True value next. So let's do if head is none, yes, return head. Right. Okay, I guess we're stuck in an infinite loop. Make the swap. Okay, so we can't actually do that within the linked list. I didn't really know that, but okay. Let's get rid of this. Let's create a dummy node. Dummy is equal to list node 0, right? We can create cur is equal to dummy. Cur is equal to head. Dummy.next is equal to hang on, I need to think about this. Dummy is equal to list node 0, dummy.next is equal to head. I'm confused what we're doing here. dummy is equal to list node 0. Dummy.next is equal to head. Okay. Previous is equal to dummy. So this is our previous node, and then we want our cur is equal to the head. Okay, so I think what this does here is this creates a new node. Then this makes the next node equal to the head, equal to head of OG list. Prev node to swap starts at node before. Then we have our current node to swap starts at head 1 in front of prev, right? So I think cur does not equal none, and prev does not equal none. Oh wait, and cur.next does not equal none, because we don't need prev. First is equal to cur. Second is equal to cur.next. I just don't understand why we needed this, like, first is equal to cur, second is equal to cur.next, okay. Then we want to swap prev.next. We're creating all these different ones so we can have all these different pointers. So we have our prev is our dummy, so then we have prev.next is equal to second. First.next is equal to second.next. Second.next is equal to first. There's so many different pointers, dude. Like, holy shit, dude. Move to the next pair. Prev is equal to first. Cur is equal to first.next. Bro, why are there so many freaking pointers, dude? What? This must be unnecessary, bro. Like, what is going on here, bro? Okay, that's what I thought. Okay. What the hell is going on here? Okay. I'm gonna visualize this here. So we have our dummy, which I'm gonna start with D. Right? Then we have our 1, our 2, actually, our 1, 2, our 3, 3, I guess we can add our null node. Actually, no, we have null. Okay, we have our null node, right? So here we make our dummy.next is equal to head, prev cur. Dummy.next. Okay, so our dummy.next here is equal to head, makes this equal to this, right? Points it to this. We have our prev, which is here. And then our cur. Jeez. Whew. I think the reason why I realized all this is we're doing the links. While code is not equal null and code on x is not equal null, right? So our code on x is not equal null and our code doesn't equal null, so we enter the loop. So first is equal to cur. So I'm just going to do one swap here so we can get the idea. So we make okay, so I think what we're doing here is we're identifying the nodes to swap, right? So I'm going to mark this with f, first is equal to cur, cur.next is equal to second. So these are the nodes that we want to swap, right? Second. Then we swap. Our previous.next is equal to second. Previous.next is equal to second. So this changes to 2. Right? Wait. Okay. Previous.next is equal to 2. Previous.next is equal to second. Dummy. Okay, so the dummy now points to 2. Right? So we break this link. Dummy now points to 2. Okay, I'm understanding what they're doing here. So prev.next is equal to second. First.next is equal to second.next. First.next is equal to second.next. First.next is equal to second.next. 1 now points to 3. So 1 now points to 3. So we broke this connection. So 1 now points to 3. Second.next is equal to first. Second.next is equal to first. 2 now points to 1. That's what I thought. Okay, so 2 now points to 1. This is really confusing. Why the fuck are we changing all these connections? I don't know. Move to next pair. Prev is equal to first. Prev is equal to first. So prev is out here. Cur is equal to first on next. What? I don't understand this. I understand that dummy points to 2. I don't understand, dude. I'm confused. Swap every 2 adjacent node returns. So you must solve the problem without modifying the values in the list nodes, i.e. only the nodes themselves may be changed. Ah, okay. 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 No wonder why I was thinking earlier we could just swap the nodes like that, but you can't. Okay. You're actually going to change their references. So that's what we're doing here. We're changing all the different references. Okay, that's why I'm getting... Bro, this shit is so confusing. Like, so what we got to do is we got to put 2 here, put 1 in the dummy. This is frustrating, bro. First and second. First is equal to cur. Second is equal to cur on next. Right. So previous dot next, so the link is equal to second. Previous dot next is equal to second. Is equal to second. No, previous dot next is equal to second. So this link goes here. First dot next is equal to second dot next. first and second, yes. We update prev.next is equal to second, so dummy now points to 2 instead of 1. Okay, I think I'm understanding this now. Okay, hang on, wait. I think I might just had a light bulb moment here. Okay, so we start off with prev.next is equal to second. So we change this link. This link doesn't exist anymore, right? Then we do first.next, which is this link, is equal to second.next. So therefore, this link is broken here, right? So technically, it looks like this, right? We have the D for dummy, right? And there's no link. Okay. First.next, so we're breaking this link technically. And we're empty here. And we have 2. So it looks like this. We have 3. Goes like this, right? This is what our link looks like right now. Second.next is equal to first. We update second.next equal to first, so 4 now points to 3. Oh shit, man, this is so confusing, dude. Like the links, bro. So confusing, like. Second.next is equal to first. So I think second.next, I think this goes back here. Okay, wait, I think from what I understand, we now have 2 is here, right? Because like this. Then we have our 1 is here. And our 3 is equal to second. Then our first dot next is equal to second dot next. So 1 and 3 are connected. But our second dot next, which is technically pointed at 2, is equal to first, and our first is pointed here. There we go. I think that's how it swaps. That's, man, really fucking confusing. Holy shit. I don't know, bro. I think that's how it works, and I think that's why it was confusing me, was because I wasn't moving the nodes, and I was thinking, like, bro, like, what is going on here? Like, but I think that's how it works. And then we move prev is equal to first. So our prev moves here. And our cur is equal to first dot next. Cur is here, first dot next. Right, okay. So now let's do this better. So let's the dummy node and loop structure naturally handle edge cases. Let's the edge cases here. Head is equal to null, so cur is equal to none. The while cur and cur on next condition fails immediately. Okay, let me think here. Okay, so we've updated our prev and our cur. So this is where we're at right now, right? So then we identify. So our prev, our first is equal to cur. So this is first, and this is second. Okay. I think I got this wrong. Wait. Prev is equal to first, so our first is still 1. First is still 1, prev first. Oh, we're skipping a node. Are we? It's here. So then first, cur.next is second, but cur.next doesn't exist. Is this code right? Is this code right, bro? Okay, it is. understand now. Oh my gosh, dude, am I that stupid? I'm forgetting a node, bro. Jesus, dude. Oh my gosh. I was forgetting a node. Oh my gosh. Okay. Okay, locked in now, locked in. So we have... Okay, this makes more sense now. So we have... Our previous is equal to first, right? So this is our previous. Previous is equal to first. This is our cur, right? Our first is equal to cur. Our second is equal to cur.next. This is our second here. So we're swapping these two nodes, right? 1 and 2, right? We come through, we do prev.next. Prev.next is equal to second. Prev.next is equal to second. So we're breaking this, right? And then our first.next is equal to second.next. So we're breaking this, right? So then technically our node looks like this. We have 4 over here. We have 4 here. Because our prev.next is equal to second, right? Now we're here. And then our 3 is equal to null. 3 is equal to null. Right? And then our second.next is equal to first. This is our second, so our .next is equal to first. Boom. We can add on our other ones. We got 1 here, 2, D, right? Nice. And then we update our prev is equal to first. Is that prev? Cur is equal to first.next. This is our cur. Okay. We go into our while, our cur is none, or our cur.next is none. So boom, done. Iteration finished. And it covers all our edge cases too because of the dummy node. Oh my gosh, okay, I understand now. So I think the main reason why I was getting confused was because I was visualizing it and I was reading the code and it just didn't make sense with all the links. But now it does. So now I understand it much better. And I'm going to prove that. Oh, let's go back here actually really quick. Let's resubmit this. I'm going to prove that I struggle a lot with reverse linked lists. If anyone here is watching, I struggle a lot with that problem. And that's because my fundamentals in my head probably weren't right. Now I'm going to try and reverse the linked list really quick. See if I can understand it in my head. Reverse linked list. Oh shit. Retrieve. Yeah. Okay. Let's reverse link this. So cur is equal to head. Cur is not equal to none, right? Okay. We want to visualize this. Okay, not that. We want a new paint. Okay, let's get rid of this. I want a new paint, so have our values here. We have 1, 2, 2. We have, what do we do? 3, 4, 5. 3, 3, 4, 5. Okay. So our cur is this one, right? This is our cur. We want to create our next, right? So this is our next. Okay. So we want our next to be equal to cur.next, right? That's the beginning. Now we want to flip our links, right? So how do we flip our links? So we want to flip our cur.next. No. Okay, hang on. We want to flip our links here, so we want to hang on. Return the reverse list. Man, bro, I'm telling you, this is like the hardest easy problem out there, bro, reversing linked lists. I find it so hard. I don't know if it's just because maybe I'm stupid or something, but I find it so difficult. Like, and I said that this was going to be a short video, but we've been here an hour and 14 minutes, so it's okay. Okay, our next here, we want to break this link, right? Equal to, we're reversing the whole list, aren't we? Yeah, 5, 4, 3, 2, 1. Bro, what? Dude. Oh, okay, I understand. We're just reversing the links. Okay. Holy shit, lock in, lock in. Okay, we're reversing the links. So that's all we're doing. We're just changing it to this, right? Not like this, just changing our links. Okay, so we want to remove this link here. Okay, we're gonna make our previous, okay? Previous is equal to do we have to make a dummy node as well? I don't remember, dude. I generally don't remember. Okay, create our dummy. Make our oh my gosh, dude. Okay. Okay, previous is equal to dummy, right? Or do we just... No, we don't need a dummy. We just make our previous equal to 0. Alright, let's get rid of this really quick. Control Z. We add in our previous. So we have our previous first. Terrible P. Another terrible P. Previous. We have 1, 2, 3, 4, 5. 1. 1. 2. 3. 5. Shit, 5. And then we have our none. 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 Okay. Sweet. Okay. All right. So we have, this is our current. So our current, and we have our next. Maybe we do have to create a list node. List node 0. Dummy is equal to list node. Prev is equal to dummy. Okay. Fuck it. We're just gonna make a list node. Fuck this. Okay. Then we want our current next. We want our two. We want our 2. So pretty much what we want to do is we want to break this link, I think. We want to go here, break this link, and then okay, let's go by steps first. So let's break this link and move this here, right? So let's do code.next. Actually, no. We want to do, let's break this link and do code.next is equal to prev. Code.next is equal to prev. I think that's where we're going with this. Get rid of this link. Then you do bro, lock in, bro. Oh my gosh. There's so much concentrating, bro. Oh my god. Okay. Bro, I just gotta keep doing problems like this, bro, to like think about it, like, and it'll eventually like click, and I'll be able to like do it on the spot. Code on next. So what would be the next? It would be no, technically we broke this link. Right? Nice to have the other diagram right now, but we broke this link and we've changed this link, right? We moved it to here. Prev is equal to dummy. So this This link here doesn't exist either, so I'm kind of tripping. This doesn't exist either. That's gone. We have our reference here. On our next dot next to be equal to cur. So we took away this link and we made it this. Oh wait, no. Well, how are we gonna get there? Cur is equal to next. Okay, so cur is now here. Right. Got rid of that. Wait, no. Well, the thing is, like, we established this link here, right? Code on X equal to previous. We established this link here, right? That's the link that we lost. We moved cur to here. So it's like, we go next up, but then we don't have a way to get to 3. So I think we bring this back. Maybe we do prev.next is equal to cur. I think we're gonna look at the submissions, dude. Bro, I bet you I was so close too. Like, I was, bro. Man, fuck me, bro. We don't need the dummy node. It doesn't matter. I don't even think it really fucking matters, to be honest. Next is equal to code on X. That's what I got. Before I had this, I had code on X is equal to prev. And what did I have? Prev is equal to cur. Didn't think about that. Fuck! Fuck. I was confusing myself because... Okay, let's restart this. Okay, let's restart this, right? Okay. Get rid of these links. Oh my gosh, dude. This is literally the most ace thing ever. Like, okay. Fix these links. Okay. So this is our dummy node. It's our dummy node, right? Our dummy. I think it's honestly got 0 in it. It honestly, like, I think it's honestly got 0 in it. Right? You list on 0, yeah, okay. So this is our prev, right? Prev. This is our cur. This is our next. Okay, this is what we got here. Next is equal to code on next. Code on next is equal to previous, right? So our code on next, we break this link, right? I don't think there is a link here, actually, believe it or not. Yeah, no, okay. We flip the link, and we do this, right? Then our prev is equal to cur. And let's get rid of this. That's what I didn't think about, because I was thinking prev was a node. We got prev here, right? And then our then we want our cur is equal to next, I think. No, next is equal. Cur is equal to next. Oh my gosh, dude, this stuff annoys me, bro. Why is this not working, dude? Go back to my original. It's because we did 1, 2, 3 now. Okay. close, bro. Okay, we're gonna get rid of this shit over here. Okay. Let's create our prev node, right? Prev is equal to none. Oh, okay. I think I understand. So we do. This is our head 1, right? We have our link. We have our link, which is 2. So we do next is equal to code.next, right? So yeah, okay. So we have our prev here, right? Just our random prev node out here. Like prev is equal to none. So it's like, I guess just like an empty node, a null empty node, I think. Just like floating out in the middle of nowhere. All right, this is our prev. I think this is the way I'm kind of thinking about it. All right, we do our code.next is equal to prev. So we break this link. All right. Okay. Prev is equal to cur. So then we move shit. Prev is now here. Right. Cross this out. And our cur is equal to next. This is our cur here. Break this link. Right, then we go through again, we do our next is equal to code.next. Break this, our next goes here. Okay, our cur, we break the link, right? Break this link. Sorry, this link is meant to be the other way around. So our code.next is equal to prev. So prev is here. Right. Then we update cur. Prev is equal to cur. Prev is equal to cur. Get rid of this, we have cur over here. Right. Then we do it again, right? Next is equal to code.next, so we move this next here. We break this link. Break the link. Move it. Oh, sorry. Break the link. Our previous is equal to cur. Code.next is equal to previous. The previous here. Yeah, we move previous. Move previous. Then we move cur. Then we move our next pointer here. We break our link. Break our link. Then we put our new link. Then we move. Go. Sorry, our previous here. Right, and then our curves here. Then we do one more, we break our link. Sorry, no, forgot. Put our next is equal to null. We break our link. We break our link, right? We replace our link. We move our prev. Get rid of it. We move our cur. Our cur is over here. Then our loop stops and we return prev. And prev is pointing this way. We have 5, 4, 3, 2, 1, null. Nice. Okay. Oh my gosh, dude. Okay. Thank you guys for watching. We went kind of for a long time. I wasn't expecting to go for that long, but I think it was good to kind of wrap that understanding and everything. I honestly thought I thought that was really great. Kind of really learned what we're doing with linked lists a little better. Jeez. This one was a tough one, but I'm happy that I looked at it because it definitely helped me kind of think about the ways I need to be doing it. Having all these different pointers and everything. So I think it definitely really helped me. So we'll probably keep looking at some more of these problems. Hopefully there's more actually. I don't know. Maybe this hard one could be something similar. I don't know, but we'll figure it out. Anyway, thank you guys for watching. I'm going to bed. I will see you later.